Use the data in the following table, which lists drive-through order accuracy at popular fast food chains. Assume that orders are randomly selected from those included in the table. First thing we want to do is add up all the columns and then add up all the rows and then find the total of all the restaurants that are involved. So if we add 337 plus 336, it gives us 373. Restaurant B, 274 plus 56 is 330. Restaurant C, 233 plus 32 gives us 265. Restaurant D, 130 plus 15 gives us 145. If we add the entire row for order accurate, those four numbers, we get a total of 974. Add the total row for order not accurate, that gives us 139. And if we want to find the total overall, we can either add the column here in the total or the total row, and that's going to give us the amount of 1,113. Now the question states, if two orders are selected, find the probability that they are both accurate, and then complete parts A and B below. So if we're looking at the order of accurate, that means there's 974 that's total for the order of accurate, and the total amount is 1,113. So the first part is, assume that the selections are made with replacement. Are the events independent? Now, to find the probability that event A occurs in one trial and event B occurs in another trial, we multiply the probability of event A by the probability of event B. But be sure that the probability of event B is found by assuming that event A has already occurred. This approach is reflected in the formula below. We have the probability of event A and B is equal to the probability of event A times the probability of event B, provided that A has already occurred. Now, in this situation, the simple event is selecting an order from a restaurant. So when selecting an order from a restaurant, there are n equals 1,113 different orders from which to select. Now we want to count the number of orders that were accurate. So if we come back up here, we saw that the orders that were accurate were 974. So there were 974 orders that were accurate. Now you're going to divide the number of orders that were accurate by the total number of orders to calculate the probability of selecting one order that is accurate. So probability of A is equal to the total accurate orders divided by the total, which is equal to 974 over 1,113. Now we're going to let A be the event that the first order is accurate, and then we're going to let B be the event that the second order is accurate. And therefore the event B be the event that the second order is accurate, given that the first order is accurate. So recall that the selections are made with replacement. Because the selections are made with replacement, the events are independent events, and so the probability of each order being accurate is not affected by the other orders. Therefore, we would say that the probability of B is also equal to the probability of A, which is 974 over 1,113. Now what we're going to do is multiply the probability of event A by the probability of event B to obtain the probability of A and B occurring, and then rounding it to 4 decimal places. So the probability of event A and B is equal to 974 over 1,113 times 974 over 1,113 to give us the following decimal: 0.765821553, which gives us 0.7658. Now, therefore, assuming that the selections are made with replacement, the probability that both orders are accurate is 0.7658, and therefore the events are independent because the sampling is done with replacement. Now keep in mind here, whenever you multiply these two together, what you're going to do is just make sure that you put in parentheses 974, divide that by 1,113, and then parentheses 974 divided by 1,113, and make sure you close the parentheses to give us that result. If you don't enclose that fractions with the parentheses, then your order of operations are going to be off according to your calculator. Now let's take a look at part B. Now for part B, it says, assume that the selections are made without replacement. Are the events independent? Now, the probability of event A will be the same as the probability of event A in part A, meaning that the probability of A is equal to the total accurate orders over the total, which is 974 over 1,113. Now, when replacements are not used, the events are not independent and the probability of event B changes depending on the outcome of event A. Since event A was selecting an order that is accurate and selecting order does not get replaced, the number of orders that are accurate and the total number of orders to choose from each decrease by 1 when choosing event B. Therefore, we would say the following. The probability of event A stays as 974 over 1,113, and now the probability of event B, provided that A has already occurred, is now we're going to subtract 1 because it's without replacement, so we need to subtract 1 from the 974 to give us 973, subtract 1 from the 1,113 to get us 1,112. So now what we're going to do is we're going to multiply the probability of event A by the probability of event B, given that event A has occurred, to obtain the probability of A and B occurring, and then rounding it to 4 decimal places. So here is our result. The probability of A and B is 974 divided by 1,113 times 973 divided by 1,112. So again, let's go ahead and do this on our calculator. So if we take the calculator of 974, make sure you have your left parenthesis, divided by 1,113, and then times 973 divided by 1,112, and that should give us this decimal here, 0.765723270. And then we're going to round that to 4 decimal places, which is 0.7657. Therefore, we would say the following. Assuming that the selections are made without replacement, the probability that both orders are accurate is 0.7657, and the events are not independent because the sampling is done without replacement.